Now, first thing we're doing is section 8.1 trigonometry identities. Okay. Now, the first thing I want to talk to you about is just about trigonometry identities or trigonometry functions in general. So if I had, let's say, cos 30 and then cos 45. Functions don't obey conventional maths. What I mean by conventional maths is cos 30 plus cos 45 does not equal cos 75. Okay, you can see that all day long. If you want to prove that to yourself, you just put in the calculator. Cos 30 is root 3 over 2. Cos 45 is 1 over root 2. Add them together, you get 1.57. Cos 75 is uh, cos 75 is 0.26. Okay, they're not equal to each other, so there's no adding effect of cosine functions. Okay, same way there's no multiplication effect either. Next thing you're going to do, sometimes a common thing I see done is if I see cos 30 divided by 15, people think you can divide the 30 by 15 and get 2 or cancel the causes. You're simply not allowed. The cos and the 30 and the cos and the 15 belong together. They cannot be separated unless you use cos inverse or sine inverse or specific trigonometry rule. Essentially, they are one number. So they're bounded together and they're one number, and you move them together at all times. Okay. Next thing we're looking at is new functions. And they came up with these functions just to save using fractions. Okay. So when you see cosecant, so if I said cosecant 30 degrees, that'll be 1 over sine 30 degrees. Okay. Same way if I said cotan 60 degrees, that'd be 1 over tan 60. 1 over tan 60 would be 1 over root 3. Or your calculator would put out as root 3 over 3. There you go. So that's all that first part means. Well, it doesn't mean anything else really. Next thing, you're talking about a well-rehearsed rule. Tan theta equals sine theta over cos theta. Now the great thing about this rule is you don't even have to remember any of this. Just design any triangle you want and any letters you want. So in this triangle, instead of using X, Y, and R, I'm just going to use my own 3 letters. I'm going to call that C, that A, and that B. I will use theta because I'm asked to prove tan theta equals sine theta over cos theta. I say no bother. Okay, what's sine theta? Sine theta is opposite over adjacent. In this case, sine theta is opposite over hypotenuse, which would be B divided by C. No bother. B divided by C. Then I go, okay, what's cos theta? Well, cos theta is adjacent over hypotenuse, which is A over C. Finally, what's tan theta? Well, tan theta is opposite over adjacent, which is B over A. Now, the right hand side is sine theta divided by cos theta. Sine theta is B over C. Cos theta is A over C. Remember what you do, you bring the fraction on the bottom towards the top and turn it upside down. Same as B over C multiplied by C over A. And what happens next is these cancel and you get B over A equals sine theta over cos theta equals B over A. And in that case, sine theta over cos theta must equal theta. Okay, and that's that proof done. Very, very easy proof. The next thing we're going to introduce you to is the mandatory proofs or key standard trigonometry proofs that are boxed separately and are flagged by mandatory proof box. Other proofs are shown in text and example. So, what I need to prove here is I need to prove that cos squared theta plus sine squared theta equals 1. Now, next thing I'm going to introduce you to is a website. The website I'm going to show you is what's called emaths.ie/log tables, and this gives you the log tables of the this will give you the log tables of the full of the your log tables, right, if you don't already own. Now what I'm going to ask you to do is go to page I believe it's page 14, I believe. Now see this on page 14. So we're just going to chop and change this out here for a second. This is a unit circle given to you in your notes. Okay. Now the thing is about I'll also grab XY axis while I'm at it. Give me a second. Okay. Now let me explain how you can use and how it's used generally speaking. Right. So imagine the case where we're having a geometry question, all right? And I can give the points as I can give the angle as I give you the point 3, 4. Right? Now, 3, 4. When you start off with 0 means 3 across, 4 up. Everybody knows that. Everybody's happy to do that. Okay. Now, what this does is there's what's called polar coordinates, and polar coordinates use angle that starts in positive x-axis. So imagine your angle starts here, it goes all the way to wherever your line may be. In this case, the line stopped here. And I can find out this angle quite quickly. Sorry, WhatsApp on, I'm supposed to, I was looking to get their website. Okay. And so it's 3 and 4. If I do Pythagoras' theorem, which is the hypotenuse, and I say x squared equals 4 squared plus 3 squared, x squared equals 25, and then x equals 5. Right there. Right, so that's x equals 5. Now, there's also what's called polar coordinates, where the x-axis is r cos theta and r sin theta. R is the radius of the circle that point would be on. So if I was to put this into a circle, so you can see that it could be part of a circle if it wanted to be, where the r value would be 5. Now, if I was asked to find the angle here, I could tan inverse 4 over 3. So if we do tan inverse 4 over 3, what I'll get is 53.13. So tan inverse 4 over 3, 3.13. Now, I could change these coordinates here into 5 cos 53.13. That could be 5 sine 53.13. And that's how these work. Okay, and if I put that back into my calculator, if I write down 5 cos 53.13, I actually get 3.000. 3, if I put that into my calculator, I get 3. If I put that into the calculator, I get 4. It's basically just a different way of writing coordinates. Okay, now in this case, you're not using a radius of 5. They decide that they want you to use a radius of 1. So your coordinates aren't r cos A and r sin A, because it reduces the r value down to 1. So your r value is actually just going to be 1. So this means your angle is cos A and sin A. So you can draw this diagram here, and you use the red point here. See the red point, cos A sin A, and use the green point, which is 0, 0. And what we just want you to do is we want you to get the distance between these 2 points. Because it's a unit circle, it's of distance 1. So a equals the square root, and we're going to use x2 minus x1 squared from geometry. We're going to use y2 minus y1 squared. And we're going to use the point 0, 0 as our x1, y1, and this one as our x2, y2. And what we're going to get is d equals cos A take away 0 squared plus sin A take away 0 squared, squared out, and is cos squared A squared A, and we know that the distance is a unit circle must equal 1. Then we square both sides and we get 1 equals cos squared A q e quadratum chatum. It's Latin for this is what you're at. Okay. Now let's move on from all that. Now we're going to prove a different. Equation from your log tables. Now see these formulas here. Cos squared plus sine squared equals 1. all in the actual log tables here. You can see up in the top right corner here, just cos squared A plus sine squared A equals 1. And then the next one is secant squared A equals 1 plus tan squared A. Now, what does that mean and where does it come from is what you might be asking. Okay? So, let's figure this one out. You start off with sine squared A, sine squared theta, cos squared theta. And what you notice is you have tan squared theta. So the way to learn this off is divide both sides by cos squared theta. Okay. Now, what you learned on the first page, if I go all the way back to the start, is that secant A, sec A there, secant A equals 1 over cos A. Square both sides, and you get secant squared A equals 1 over cos A. So, when we go back here, I can say 1 over cos squared theta is secant squared theta. Cos squared theta over cos squared theta is simply 1. And then this is sine squared theta over cos squared theta, which is the same thing as sine theta multiplied by sine theta divided by cos theta multiplied by cos theta. And both of them can be changed into tan theta, which is quite simply tan theta. And this proves this formula that we're asked to prove here. Alright, hopefully that explains everything. Now, we've established that one, we've proved that one. Now, once again, if you go back to the start, cotan theta is 1 over tan theta. Tan theta is 1 divided by sine theta over cos theta. Remember what I always say, if there's a fraction on the bottom, bring it to the top, turn it upside down, like so. And now you can see that tan theta is actually equal to cos theta over sine theta, because you're multiplying theta. We've done that, proven that, and we've proven that. So we've done all 6 of them. Now we can move on. Now, follows from 5. Oh yeah, this is very easy. These two here, very simple, but I'm also going to show you a little add-on from these as well. So remember we have cos squared theta plus sine squared theta equals 1. Well, just move over, let's say, the cos squared theta. Sine squared theta on its own is going to be 1 minus theta. Next thing, you ever remember the difference of two squares? Where x squared minus y squared is x plus y minus y. The thing to remember about these ones is you can also change that into 1 plus cos theta and 1 minus cos theta. Because if you multiply that out, you get 1 minus cos theta plus cos theta, and then you're finally going to get minus cos squared theta, and the two in the middle thing. Likewise, cos squared theta on its own, if it was to bring the sine squared theta over the other side on its own, cos squared theta equals 1 minus theta. Okay? Okie dokie. Now, having proved all that, we can now jump into this, and you're going to find some of these are very, very easy, right? So let's, I'll do some of the odds. Question 1, cos A tan A equals sine A. I always identify the simpler side or the more complicated side. This is the more complicated side. I'm going to change it. Change one thing at a time. I'm going to change tan A because I believe I can change tan A into sine A over cos A. And then what I believe I can do there is I can just cancel the cos A's, multiplication on top, division on the bottom. I'll just get sine A equals. So that's quite easy, right? That's question 1 done. Now, in this one here, I believe that question 4 is the more difficult. expression. 1 followed by 4. Now, see the 1 minus sine squared theta? Looks a lot like what we were doing earlier with the cos squared theta. So I'm just going to change that outright. So this one here, change that blue part for sine theta equals 1 over the square root of theta. Then when you square root cos squared theta, you get sine theta over cos theta equals tan theta. And then tan theta equals theta. So that's 1 and 4 done. Next, I suppose people will think 6 is harder. So we go for 1, 4. Now in question 6, once again, cos squared theta is the easy one. It's the easy side. Theta is the easy side. Right? So we're thinking of how do we turn the left hand side into the right hand side? What do we do? Well, what I'm thinking is I'm going to change the tan squared theta, because the tan squared theta is speaking a completely different language. I'm happy the way both of them are causes, but I'm not happy with that tan squared theta there. So what I might think about doing there is I might do, okay, tan theta equals sine theta over cos theta. Okay, that's great. Square both sides. Tan squared theta equals sine squared theta over cos squared theta. To me, that's a move in the correct direction, because I now have, that's the perfect move. Cos squared theta cancel. I get 1 minus sine squared theta cos squared theta. We know from earlier, a couple of steps backwards, that cos squared theta equals 1 minus sine squared theta, or sine squared theta equals 1 minus cos squared theta. So we must cos squared theta theta. So that's 1, 4, and 6 done. Handy out. Now, which one technically looks harder here? So 1, 4, 6. I'm not going to do 7 because I hinted on 7 earlier. So you might want to have a look at 7 yourself. There's a hint here. Just a hint down here earlier when I said that you can express this of 2 squares. Please remember that. Come in handy enough. Now, or you can just multiply back. So we'll do 8. 8 looks a bit more. Now, I'm going to change secant squared a. Secant a is the same thing as 1. I think there might be something here I can use directly. Secant squared a equals 1 plus tan squared a. That's a handy one actually. So I don't even have to go through all that. Secant squared a equals 1 plus tan squared a. And then I can just say 1 plus tan squared a minus tan squared a equals 1. Cancel, and just get 1 equals 1. 1, 4, 6, 8, handy enough. Now, we'll try 10. 4, 6, 8, 10. Now, 10 is 1 tan squared theta multiplied with cos squared theta equal. Okay, I'm always inclined, I tend to get rid of the tan squared first. Let's see what I'm going to do. I think I'm going to do what I did last time. Tan theta equals sine theta over cos theta. I'm going to square both sides. And then I'm just going to say it's 1 sine squared theta over cos squared theta multiplied by cos squared theta. I'm going to multiply that out. 1 times cos squared theta is cos squared theta. And then when I multiply sine squared theta, cos squared theta, cos squared theta, cos squared theta cancel off and just leave over the sine squared theta. Yeah, and then we just get that general proof. And it's on page 14 of your notes. It's going to be 1 equals 1. That's easy enough as well. So that's 1 4 6 8 10. I suppose the harder one here is 12. So in question 12, you're going to have 1 plus pausing it and having a go at this stage. Now, once again, seeing 1 plus tan squared a somewhere before. We go to my notes here. There it is. 1 plus tan squared a is secant squared a. So I'm going to change this outright for secant squared a. And I know secant squared a is the same thing as 1 over cos squared a. Likewise, 1 minus sine squared a, I know that to be cos squared a. And 1 over cos squared a divided by cos squared a, we know they're going to cancel. That's going to be 1 equals 1. So which one was I doing again? Question 12, yeah, 12. Quite easy as well. They do take a while. I remember when I was first doing these a couple of years ago. You get used to them. Now, next one. We can go for 14. Yeah, how far does this go up? Each time. Okay, and this one's fair. 1 minus cos squared a, as we discussed earlier. You do sin squared a plus cos squared a equals 1, and then sin squared a equals 1 minus squared a. So change that with sin squared a over sin a cos a tan a. And you say that cancels with that one. Then you have sin over cos a, which is a equals a. Now, examiner, you might not show it like that. You might show it as sin a over sin a and sin a cos a, and then you're just going to show a. Hey, so that's 14. Okay, next one we're going to do is nobody likes fractions, so let's do 15 this time. 15. Alright, but not just 23 minutes now, so that's a good long while to be doing this. So let's keep going. Now, I don't like fractions, and they don't like me. So I'm thinking the simpler side is this side here. Okay, and we're just going to leave that alone for a minute. Next thing I'm going to do is going to get common denominator. So it's going to be this denominator. So I'm just going to highlight them with colors. Denominator, green denominator. The blue denominator goes above the green denominator, so it's going to be 1 times 1 plus sin a. And then the green denominator goes above the blue denominator, which is going to be 1 into 1 minus sin a. And then it's the green denominator multiplied by the blue denominator, which is 1 minus sin a. Secant squared. I'm going to multiply this out. I'm going to go 1 plus sin a. And it's going to be 1 minus sin a. Multiply this out. We're going to get 1 plus sin a minus sin a. And minus squared a. Okay. Now, on top, sin a is cancelled, so it's going to end up with 2 on top. On the bottom, I'm going to end up with 1 minus a. As we know, we've used this several times today already. Cos squared a plus sin squared a equals 1. and then 1 equals, oh, sorry, 1 cos squared A equals 1 minus sine squared A. Yeah. 2 over cos squared A equals 2 A. And remember, 1 over cos A is, and then 1 over cos squared A is secant squared A. The answers are the same. 2 over sec squared A, sec, as they say sometimes. 15. Done. Let's see what the next one will do here. Let's say 17. Looks harder. So 17. I'm going to try and find out what cosecant means. I've already forgotten. That's what your tables are for. Your tables are finding out what cosecant is. So have it here. Oh, there it is. Cosecant is 1 over sine A. So good old tables. Is 1 over theta. Square both sides. 1 over sine squared theta. Just give me a second. The parenthood call, so I'll do question 17 another day or on a separate video. So, yeah. So we did to sum up, we did the 2 proofs and we did those questions.